Unit 10, Day 8, is going to be talking about the applications with the law of sines and cosines. So we've already learned how to do sines and cosines. Now we're going to talk about how it works. What are we going to do with them now? Real world type applications. So on the first page here, they're talking about us going through and identifying if it's a perfect setup for law of sines or law of cosines. So when I take a look at the first one, there is no x in this picture. The x is supposed to be here. And then I start matching up that side with the angle across from it, and this side that I know with the angle across from it. I can see I have two sets of sides with angles across from them, so that very clearly is going to be a law of sines question. I usually try to look for law of sines first. I think it's a little easier than law of cosines, so I'll look for that first, and this is a perfect setup. When I look at the next question, I'm looking for this side of x, and I do have the angle across from it. However, I don't know either of the other two angle measures, nor can I figure them out. So this is not going to be a law of sines question. However, I do have the two sides that force that angle to be included, which allows me to use the law of cosines. So this is very clearly a law of cosines question, very typical law of cosines question. When you get to the third one here, believe it or not, you're going to be tempted to start looking at this as law of sines or law of cosines, but it doesn't even need to be that difficult. In this particular question, you know two sides of a right triangle and are looking for the third. So the quickest way to do this question would be to go through and use Pythagorean theorem. Not that you couldn't use law of sines or law of cosines, but probably you're going to think that that's easier. So I'm going to have you flip your page now. I want to go ahead and take a look at some of the application problems. And we're not going to do all of them. There's a lot of them here. So I don't want to go through and do every single one of those with you. I would like to switch to the next page even. Go over to question 3. This is a very typical question as far as using the law of sines and law of cosines. So they tell us that we have two lighthouses that are 30 miles apart, one on each side of shorelines running north and south. It says each lighthouse keeper spots a boat in the distance, so you can see they're both looking at the same boat over here. One lighthouse keeper notes the location of the boat as 40 degrees east of south, and the other lighthouse keeper marks the boat as 32 degrees west of south. So we do kind of have to take a look here about what that means. They're asking for us what's the distance from the boat to each of the lighthouses at the time it was spotted. So I'm technically in this question looking for this and looking for this. Now, they've got a little direction here telling us that this way is south. So when this lighthouse keeper is here and he's looking out at the boat, he is saying south goes this way and he's 40 degrees to the east of south. And the other one, lighthouse keeper here, knows that this is south and the boat is seen 32 degrees to the west of south. So on our little compass here, we might want to write in the directionals. That may help some of you. In any case, those are the angles. They did give them to us, so we didn't have a lot to do in this question. So as I go through and I take a look at what we have going on here, these two angles are right angles in both of the corners here. That allows me to figure out the complementary angles that are inside the triangle. So that is extremely helpful. And in this particular question, because I know those two, I can also figure out that the angle right here is 72. So in my triangle, because the angle's at 180, so in my triangle, I really do have quite a bit of information. I have all three angles and a set of sides. So I'm going to start by looking to solve for the x first. So I'm looking for this x that's right here. That's across from a 58-degree angle. And I'm going to use the relationship of this 30-mile side across from the 72-degree angle. So I have a situation where I have two sets of angles and sides across from each other. So I'm going to use, I guess I'm going to use 30 over the sine of 72 equals x over the sine of 58. So that's going to allow me to go through and solve for x. Because we've already spent some time talking about how to solve, I'm going to tell you that when I cross multiply and go through and solve, I do end up getting 27. So make sure you could do that math and get the right answer. And then I'm going to go in and I'm going to solve for y. And this side of y happens to be across from the 50-degree angle. And then I still have this relationship, the side and the angle across from each other. So I can go in here now and I can say, again, that I have 30 over sine 72. And that's equal to y over the sine of 50. Cross multiply and solve, and I end up getting that y is 24. Those are routed to the nearest mile. So I was able to find both of those two measurements that are there. I'm going to have you flip back one page. These questions I wanted to talk about also. I know that the other one was a little bit more involved, but I do want to talk about these as well. I think I'll work on question number 2. And in question number 2, we're talking about a triathlon. It's starting here, and it says the race begins with a 3.5-mile swim, and then continues with a bike ride for 4 miles. And they want the race to end at the same place it started. So in order for that to happen, we need a 30-degree turn here. For the triathletes to get back to where they started. In this particular question, it says that we are supposed to identify which way we want to go through to find what the total length of the race is. So are we going to use Pythagorean theorem? Are we going to use law of sines? Are we going to use law of cosines? So we have a little bit of thought that has to go into what it is that we're looking at here. One of the things that I know is that I have to find this measurement that's here, because the whole race works its way around that triangle. So as I'm looking and I start crossing things out in my mind of things that I can't use, if I was to consider Pythagorean theorem, can I use that? Right away my answer is no, because there's not a right triangle. Sorry, right angle. It has to be a right triangle to use that. When I go through and I start looking at law of sines, and I question that, I do have one side and an angle across from it, so that's helpful, but I don't know nor can I find either of the two angle measures. So in this particular case, in order to use law of sines, the answer is no, only one angle given. And we would need to know or be able to find another one in order to use that. When I go to look at law of cosines, the answer to this is yes, I definitely can use law of cosines, because in this I've got side x across from the 30-degree angle, and I also have the two sides here and here that make that angle be the included one. So this is a perfect setup for the law of cosines. So in this, I have x squared equals 3.5 squared plus 4 squared minus 2 times 3.5 times 4 times the cosine of 30. And I'm going to go through, I can type that all into my calculator. I'm going to put a couple of numbers here though, just to make sure that you know what you're doing. Go through, I end up with 4.001288694. Square root both sides. And I end up getting that for my value for x. In this particular case, they're telling me that they want to know what the total race is, so I need to go back and say, I know I'm taking the x value that I got plus the 3.5 plus the 4, and I will end up with 9.500322148.